Hi, so I'm Eitan Schwartz. I'm going to have a slightly deeper look into this POC that we provided here for boosting and the capabilities and performance of white boxes. We're at the BCE 2018 conference. We're going to start with showing a white box. In this case, we're using a white box that has a x86 inside, and it's hosting a number of VNFs. The VNFs that are hosting it here are the Juniper VSRX as a router, and also RAD's vAccess VNF. This vAccess VNF does a few functions. We're going to be showing that it firstly enables the access via MLPPP or PPP. So this is for use cases where the customer's out of footprint and the only connectivity to him is traditional T1s, E1s, T3s, and E3s. And so the vAccess VNF does this MLPPP function. We will later be also looking that the vAccess VNF also monitors the performance of the network and also monitors the performance of the VNFs inside this box. So let's shift now to the first part of the demo, where we are going to be running a video session through this white box across the routers, through the vAccess, on the two T1s to a Cisco router. So one of the strong points about MLPPP is that it is interoperable with third-party routers, core routers from Cisco, Juniper, and others. And so here we go with the video conferencing session. Video client on the one side, video server on the other side. We're going to have Ronen start this test off. Ronen. So let me just add here, before we start the video, on that white box, I spoke about the VNFs hosted. Here we see on the RAD's management system, we see the individual VNFs loaded. We see here the VSRX. We see the vAccess loaded. We're also showing that we've loaded the video server also as a VNF on the same white box. Ronen, do you want to now maybe show the video? Okay, so we are now running over, let's have a look here. Are you doing one T1 or two?
Two T1s.
Okay, so two T1s. So we're running a video session over two T1s. And then what Ronen's going to be showing, so this is a limited bandwidth application. Video is quite bandwidth extensive. We're now going to unplug one of the T1s and see what happens. What we'll see is that the video quality starts becoming very poor. As you can see here, it's actually frozen for a while, and then it starts again, and it's going to start and stop because one T1 bandwidth is just not very good for this. When Ronen plugs the T1 back in, it will re-establish the MLPPP session, the additional bandwidth, and the video will run much better. Now, in addition to running the video, we're going to be showing the performance monitoring. So let's go back over here to the PowerPoint. We just looked at the traffic running from the video client across this MLPPP session. We're now going to look and say, all right, well, let's also monitor the performance of this connection. And so we're going to be monitoring, as I said, the same vAccess VNF that has such valuable real estate here on the white box, also has the PM capabilities, and it's going to work opposite a standard PM controller that supports TWAMP. In this case, we're using our SFP, the MyNet, as a controller because it can be a TWAMP generator as well. And so we're going to look at the performance monitoring, and we're going to have a look at this on the same management system. We'll show the PM the performance of the connection. Ronen, do you want to switch back to RAD view? So here we're back to the screen, moving from the VNF instances to RAD view management. Here we're seeing two TWAMP sessions. we're seeing the one TWAMP session, which is the end-to-end monitoring, and the second TWAMP session, which is monitoring the individual VNF. So now if we zoom into one of these, let's say that we zoom in, you then have in this chart, for example, average delay round trip. But if we click over here on chart type, you'll see that you're able to see charts showing packet loss, delay variation, and many other different charts. So this is really part of the performance monitoring. Okay, so if we shift back to the PowerPoint, you'll see we've done the TDM, we've done the video streaming, we've done the network performance monitoring, and we've also done monitoring of the VNFs that are service chained here. So we have a pretty ready-to-go solution that not only can work over regular Ethernet connections, but it can work over TDM as well as Wi-Fi, LTE, and others. So now we're going to look at this customer B location. What we're going to show you is a remote location. Here we're talking about a thin CPE. We're using the MyNet standalone to do that. Connecting across a connection with MACsec encryption. And we'll show that as an SFP plugged in that does wire speed encryption. It goes also back to the central site location, and where the encryption is done again, and then it goes into a host where the video server is being hosted. So let's have a look at the components in a little more detail. The first thing is the MyNet standalone. So here we see it's an Apple TV size box with 2 combo ports. What we've done here is we've plugged in, as we saw in the diagram, an SFP that will be doing wire speed MACsec encryption. We've plugged the video server into its other port, and this device does acts as the thin CPE and adds additional capabilities such as performance monitoring, packet capture, microburst analysis, and so on. The second item that we spoke about on the far end is another SFP to do the MACsec encryption as well. And then we see over here that this box will be acting as the video server. So now we're going to shift gears, and Ronen is going to show us the function of packet capture here. We've already seen the network performance and the function of the video server with customer A. So we're going to just look at one more thing, is zooming in to this MyNet and having a look at what goes on the packets, and using the fact that the MyNet standalone and also the MyNet sleeve support remote packet capture. Ronen, if you'd like to demonstrate that. So what Ronen is doing is he's opening up Wireshark, and Wireshark allows you to select the MyNet of interest and then open up a session, and then what he's doing is he's injecting across this network ping commands, and he's seeing that along the way they are being captured here by the traffic, and these are bidirectional captures, so you've got the request and the reply each case. So the packet capture is then provided for this link. Thank you, Ronen. And with that, I'd like to end this POC. Hope you enjoyed watching. Thank you very much.